Hi guys, now we're starting from question 14. Now we have a diagram of a boat with some forces labelled on it. Okay, we've got the drag from the net, which has a red arrow, and we have the thrust from the propeller pushing the boat forwards, and you'll note that the thrust arrow is larger. So let's have a look at question A. Looking at the boat diagram, determine which way the boat is moving. Okay, the thrust arrow was bigger, therefore the boat is moving forwards. Part B, what may happen to the speed of the boat when many fish have been caught in the net? I would assume that that would make this red arrow bigger. You'll get more drag as that net fills up. Therefore, as this arrow gets bigger and bigger, the difference between them gets less and less, and you'll find that the boat will slow down. And I've said drag will increase, so speed will decrease. Part C, if the boat's travelling at a constant speed, how should the size of the force arrows be drawn? Constant speed, what you need to remember is that constant speed means balanced forces. Constant speed or no movement means balanced forces, either of those cases. If the forces were balanced, the arrows should be going in the opposite direction to each other still, but they should be the same size. Moving on now to question 15. Mariah flicks a coin across a stone bench top. Later that day she tries to flick it across sand at the beach. The coin that would travel the greater distance would be the one with the least friction or the smoothest surface, so that would be the stone bench top. What causes one coin to travel further than the other is friction. Now you can't just say friction because it says explain. And for you to explain, you need to say why the friction is greater on one surface than the other and which surface. Okay, so whenever you see that word explain, it means you have to write sentences, not just single words. So I've said less friction on smooth stone, therefore there'll be less force to slow the motion down. Okay, we also have down here, we've got 3 blocks of wood. One is on oil, one is on long round dowels, so basically wheels, and the third is just a block of wood on wood. So we'd expect with this one that there would be quite a bit of friction. With this one, because we're rolling, we're reducing friction pretty much as we can. This is how bearings work, this is how wheels work. With this one, the oil might help a bit, but it's not going to be anywhere near as good as wheels because you still have a lot of contact between those two surfaces. And depending on how thick or thin the oil is, it might not really help very much at all. So the question is, if you were to pull each by its hook, explain which block would move with the least friction and which block would move with the most friction. So it's not enough to say block A would move the slowest or something like that. You need to dissect this question and make sure that you answer every single part of it. The least friction will be B, because there's less contact between the surfaces and the dowel are acting like wheels, and which with the most friction, you have to explain why, because it says, again, we've got this word explain here. Explain why. Part A, block A, would have the most friction, and it's because the wood is a rough surface. And there's nothing there to reduce the friction. Now we're moving on to the thinking scientifically part. These are different questions. These are questions that might go a little bit further than how we went in class. It's really testing not just how much you understood, but how well you can apply the learning that you had in class. So we haven't actually looked at a block before that only had 3 forces acting on it, because in the real world there would always be the gravity force downwards, but it's not labelled on here, and we can only work with what's on this question. So we've got 15 newtons left, 10 newtons right, and 15 newtons up. Now if these 15 were pointing in opposite directions, they'd cancel each other out, but they don't. What we have here is of left and right, the left one is stronger, so we'll have some movement left, and there's that upward force as well. So the answer here is upwards and to the left. Alright, I'll now stop the video and start with the next one.